Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Good morning, good afternoon, good evening, wherever you are in the world, and welcome to Model Mondays. It is a Monday. We're here today to talk about model routers. So we've got a spotlight with the Microsoft Foundry model router. And joining me today is Sanjeev Jagtap, who is the principal lead of Core AI and responsible for the model router. So we're going to be spending the next hour with you. I'm Lee Stott. I'm a principal cloud advocate at Microsoft. Hi, Sanjeev. How are you? You good?
Yes, I'm doing great, Lee. Thanks for hosting. It's always awesome.
Excellent. So today we're going to be talking about the model router, Sanjeev. So before we get started, can you just give us a bit of an intro to yourself, who you are, what team do you work in, what's your role at Microsoft?
Sure. I'm a PM in the Core AI or Foundry team here. Right now, model router and a few other things that are related to model router. But in the past, I've done pretty much everything that we have shipped AI, starting from cognitive services to OpenAI to now pretty much everything under the sun. Yeah.
Excellent. So we've known each other for a few years, and we've been working together around model router. So I'm really excited about today's sharing, what model router is, what it can do, and we've got lots of resources. So we've got some great demos throughout this session and lots of resources to link to. So let's get started, Sanjeev. So tell us what's new in model router.
Well, we've expanded model router from 2 regions a few months ago to 5, and then on to 28 regions now, actually, and with 5 more to catch up on. So pretty soon, the goal is to have model router in all the regions where we deploy models today. And then secondly, we've added the latest Opus model, also the GPT 5.6 family as well. Plus, we have extended the agentic support to non-OpenAI models as well, to Anthropic and open source models, which was a big ask from customers. So now, those models, if you have deployed them, will also get invoked for sure. So that's one part of it. But I think it's a continuum of regions, models, capabilities, routing quality improvements. That's ongoing.
That sounds great. So, let's talk a bit about what model router is then.
Yeah, so model router effectively is really a really efficient, fast, small, specially trained language model, and that takes your prompts in real time, and really in I think almost within a 50 millisecond of latency, it will do all the analysis it needs to do, including your prompt, context, windows, tools, everything. Imagine that happening all in a matter of a few tens of milliseconds, and then routing it to the right fit model. All right, and so. But that's just one part of it. What customers also get benefit from is that it kind of mitigates the complexity of navigating the Foundry model catalog. You don't have to worry about, okay, which are the top 10, top 20, top 30 models I should be using, and evaluating and benchmarking and then iterating them as models get retired, as new models come in. So all of that complexity, and we'll talk about more, such as failovers and stuff, all that is encapsulated within the model router. So it's a model, but it's also a kind of almost your own intelligent proxy that takes care of a lot of other things, right, that you normally worry about when you use Foundry.
Cool. So it's literally just a model which is available in the Microsoft Foundry catalog. You deploy the model as you would any other model, but underneath that model is the routing algorithm to a selection of 28 models that you can customize and use.
That's right. We like to say, for customers' point of view, it is models experience. Models as customers experience it as a model, but in reality, under the covers, it's a lot more than that. It's your own platform layer, so to speak, coming in. And so that's why it is platform aware. So you don't have to deploy 35 or 28 or 27 models now. Right? That's the reason you don't see those, and you don't have to do all of that, because it is inherently platform aware and smart. Yeah.
Very cool. So, let's talk a bit about, we've deployed the model router and we've selected the models that we want to route to. How does tuning costs work then?
Yeah, so I think customers said, well, this is great. We trust you that you're doing everything right. We trust you to know our requirements. No, we're actually really not. I think we have all kinds of requirements. And yes, for a start, can you help us optimize the model router for our requirements, which at a high level could be, yes, balanced mode works awesome, which is, we kind of have a narrow quality band, as the slide shows, 1 to 2%, and then we pick the most cost-effective model. But what if we wanted to really aggressively go for cost, right? And then, so we have a cost mode where when you deploy model router, there are special properties there compared with the other LLMs. And that's where it kind of differs when it comes to deployment stage, is that you can actually select two other properties there. One of them is the routing mode, where you say, well, I want to aggressively optimize on cost. It's a simple drop down. Instead of balance, you just select cost, and that's pretty much it, and then you deploy your model. What it does is that will kind of broaden the quality bar and then give you the best model, most cost-effective model. And that's how you get more aggressive cost savings, right? And then, of course, on the flip side, you can say, no, I want to optimize on quality. I really don't care about cost. And so we'll just give you the best model based on our benchmarking for your prompts. Based on our benchmarking, but of course, targeted to your prompts based on the analysis. And so those are the three modes that we provide. And then, yes, customers, we see savings anywhere from 30% to even 80% savings, depending on their model distributions and their workloads and all of that. So all those, assuming all those variables. So there's a spectrum there, what customers can achieve.
Yeah, that's great. And again, if you look at this from an agentic solution perspective, so you're building a chat agent, you start off with hi, everybody starts off with hi. Do you really need a very large language model or a frontier model to answer hi? So you can see that progression based on quality of going from a very small language response for the initial responses, and as the questions become more complex, the models get more complex as well. So that's one of the great things that I love about Model Router.
Yeah, and that's absolutely, and that's a really valid point there, because I think customers will assume that, all right, if you're routing my prompts to the smallest, cheaper models, that means I'm getting a bad quality. In reality, it's about the right fit model. And so what customers do come and tell us is that they actually saw better quality, right, at a significant cost savings. Why? Because, if you're asking a very direct question, if your prompt doesn't need a lot of data or it has targeted data that it needs, you really don't want an essay written every time from a big model to, if you're, let's say, looking up, hey, give me the top 3 products, right, from our sales, database and so on. You really don't need a big reasoning and so on. It's really a simple lookup and drop. And so a smaller or a mid-sized model is fine enough. Versus a larger model will, of course, give you that result and will write an essay on that. So now suddenly your precision goes down. Right, you get a lot more verbose information, which is not useful, and that's why. And so that's really what Model Router is allowing to do, is just right fit your responses. The result is then customers get awesome reduced latency. The responsiveness increases. Your end users are reacting more, engaged more with your chatbots, or whatever your scenario is, and so on. So that's the kind of the downstream broad benefits, that you get really in reality.
Definitely. So to talk us through, like the architecture of how this works, because Model Router, as we said, is a model available in the catalog, but Model Router is actually just an ML model itself. It's a model that's classifying the prompt that comes in, looking at an index of available models, and then picking the best model based on the factors that you said, either quality, balanced, or cost. So how is it architected?
Yeah, so it's actually not just a classifier, because remember, it has to work within some context of what's going on when it comes to the scenarios and your prompts. Your prompts could be really coming in stateless and you really don't care about the context and the session information, so to speak, I guess, or it could be part of a larger agentic session going on. And so Model Router has to know all of that, has to understand what's the context of what's going on. It has to, if you're using Foundry tools, agentic tools, functions, and so on, it has to be aware of that, and to make sure that your agentic's experience is great, your tools are being involved. And so all of that, not to mention, customers will say, well, what about context windows, right? Some models have smaller context windows, others have larger, and so on. There's prompt caching going on. And so very complex advanced work done within Model Router and by the team on analyzing what kind of context windows should be taken into account and so on. So there's a lot of, I would say, in short, a pretty intense engineering and data science work goes into building model router and constantly benchmarking, evaluating it as new models come in. Essentially, think of it this way. It's your own curated intelligence smart set of the best value models that lie on the quality cost latency spectrum. And there's a lot of complexity that is encapsulated in this little model. In fact, I think think of this as the smallest model in Foundry catalog, if you will, because it barely takes up one GPU, but doing so much more, right? So if you just think about it in the broader picture, I think that's one way to understand and get your head wrapped around model router for sure. Yeah.
Yeah. So hopefully, there was a question from Bharat Harupal 9424 saying, do you dynamically route the queries to the most appropriate model? If yes, then how do you maintain the context? So, hopefully that sort of answered that question, Baruch, in terms of the context length and how the model works.
And I can shed some light. Great, awesome question, by the way. So what happens is also depends on which API you're using. So we know chat completion is essentially stateless, all right? And so it's coming in, that's where, yes, your models can change per request, in theory, which can happen, but then pretty soon it can go back to the same model. Now, if you're using the Foundry responses, which is the agentic API, there we actually make sure that the model is consistent across throughout each session, so to speak. And so there is that intelligence I was talking about. Now, of course, if you're using a stateless API in a scenario, even there, customers may want actually to have persistent model talk through in that. And that's part of some of the roadmap things, that we're working on, is to give you more control on that part. Sure.
Very cool. So let's just talk a little bit about, how that prompt, how does the prompt come in and how is the model selection actually happens?
Yeah, so I think this is partly what we covered in the previous slide too, I guess we ended up covering. But the idea here is that, yes, prompts arrive. And then within that, I guess it would be also interesting to talk about how model router gets built. In a sense, every new models, when it comes in, we are evaluating those models or model families on the existing spectrum that we have, and where does the models lie. Now, as your prompt comes in, and those are being analyzed, a targeted list of models is being selected. Out of those, the top models getting the most probabilistic score based on all the parameters. And remember, this is not just quality, by the way, not just complexity. There's cost, there's latency, and then what kind of prompt is that? Is it which domain, which task? All of that intelligence is being captured, and a targeted list of models is created. And based on that, depending on what customers have done, which is, remember, in model router, you can have a smaller model subset too. So you can say, don't consider all the 27 models that you do today. Just consider my preferred 5 models. So taking all of that into account, and then comes the latency part of it. Remember, if a particular model is having trouble, maybe it's having a peak load right now. And so you want to then fail over to the next best model in the same quality, cost, latency spectrum. So all of that is going on. And ultimately, of course, when you get the response, it's usually within a few milliseconds, right? But like I said, no more than 50 millisecond latency that actual routing function adds. But that's all that is happening within those a very short span of time.
Yeah, and I think another key point is about resilience. So tell us about so if I select, I don't know, the GPT family of models, and GPT-5 mini is not available because of capacity constraints or there's an issue, do I need to worry about that as a developer?
No, actually. So if you're using, let's say you've shortlisted, hey, just the 5 GPT-5 models, we'll just pick the next best model from your model subset. Or if you're just using the default model for deployment, then we'll just pick the next model from the probability list, right, which matches most closely the spectrum of what's needed there for your prompt and request. And that's one part of model router that's also customers benefit from, right? Because you can use model router as your kind of, I guess, SLA availability or capacity aggregator or abstracting mechanism, so to speak, right? And so you're kind of insulated from some of those transient errors that happen all the time if you're using dedicated LLMs, for sure. And so that's absolutely a benefit of model router.
Yeah, cool. So there's a really interesting question from Manny Cortex saying, he struggles by coding, knowing which model to use for writing code, QA debugging, writing documentation, etc. So is the model router coming to coding agents?
Yeah, so model router actually is getting used heavily actually in coding scenarios by customers today. I would say, I would say quite a healthy percentage, not the most majority, but a pretty healthy 20 to 30% of workloads, which can go up to 50% sometimes we see being used in coding scenarios, right? When it comes to model router customers. And to answer the question where I think Manny is getting into is, I think I'll answer the first question first. So yes, absolutely. So when you're sending your prompts, that is part of the analysis going on. What category of jobs are being handled here? Right, which domain, which task within those domain, all of that, absolutely. It is that goes on in real time. And remember, we don't store any prompts. Again, that's the question comes up. So, are you storing my prompts? For for months and then doing the analysis? No, we have to get everything done in real time. Remember, within 50 milliseconds or so. So we don't have the luxury of storing anything, and we don't need to. So no data is stored, no prompts are stored. This is all happening in real time. So yes, absolutely, domain classification, task classification, all that's happening. And then the other part, I think Manny says, is using high for everything gets the job done with good quality, but it's expensive. So that's the point, I think, counterpoint I was making before, right? That using a big, expensive model doesn't actually give you the best quality fit with every request and every workload. And that's the magic of model router as well, because you don't want a big model writing an essay when you're asking a very direct question. Right, and then increasing the latency, reducing the user engagement, because now you're waiting for a few more seconds to even hear, which should have been a direct answer in a few seconds, right? And so those kind of balancing is what model router brings to the table. Yeah, right away.
Yeah, definitely. And I think, just to follow up on the question, so this is really when you build in, so you would host a Foundry model, so you would go into Microsoft Foundry, deploy your model router, select which models you wanted to be made available, and then call those models from Copilot as a Foundry external model. GitHub Copilot does have a model router built in called Auto Mode. That is using a different technology, though. That's been a model trained by the GitHub team. So it's not the Foundry model router. So it's a similar concept, but a different model completely.
True, and I think, but that's a good question that comes up. So the difference is in the number of models. Remember, GitHub Auto Mode supports, I think right now, 5 model families, while Model Router supports 28. The recipes are the same. There's even data sharing that happens behind the scenes, both teams working really closely together. But because of the unique experiences that GitHub Copilot services its customers, and actually you would say M365 Copilot as well, right? So they're very different user experiences. And remember, model router is for developers, right? As the UB uses an API versus very tied to a specific user experience. And so that certainly creates, that's the reason why. It's not exactly apples to apples or 100% the same product in all 3 cases. All right.
Yeah, so we've got the next slide is around just the availability of models. So that was perfect timing of, what models are currently available.
Yeah, I think this is a very updated list. And yes, awesome animated Jeff showing which models got removed in the latest update. And that's the other value that I was pointing to, that I think that customers appreciate and they tell us. I think number one ask or feedback from customers when I say, why do you even want to use model router? And this becomes a big part of the story, is that, hey, we just love the fact that we don't have to worry about maintaining a model life cycles on our own, right? You do it for us. And so we are retiring models, we are qualifying the new models coming in, we are refreshing our list. So again, think of this as a really smart, intelligent, curated list that you can trust for most of your scenarios. And that's really the value prop. And that's really what's showing up in this nice animation. So thanks to the team there, Mary Lewis and Nitya.
Yeah, I think, this is really key. And it's something I've really loved about that model deprecation. So as Microsoft, we guarantee a model for 1 year of life. And then that model is deprecated and capacity is released and a new model is deployed. So, I built solutions using model router. And again, I don't need to worry about it. I can just go into the model selection choice. And if a model is deprecated, it's removed from the list. The new models are added to the list. We've got a great question from SharePoint Lover saying, where's MAI? Where are the MAI models? Are they going to come to model router as well?
Yes, they'll come soon. Yeah. we're working on that for sure. It will happen. No worries. No, it's a good call out. Thanks for reminding. Oh, by the way, I should say to the previous point, Lee, I should say model router itself is not versioned, right? In the sense we are just, it's an evergreen version that we're maintaining. So no, because someone might say, well, that's great, but what about the model router version itself? And no, that's why we said, okay, let's not change any versions once we went GA. And so all the updates are going to that one version of the model and that you should be using. If you're using the previous version, please switch over, because otherwise I think otherwise you'll be getting reminders and probably some shutdown messages and notifications very soon. So please migrate over to the latest version. I guess I can use this as an opportunity for that.
Yeah, definitely. And again, I think this is we talked about this capability earlier on, but this is a fairly new capability, that automatic failover if a model is not available. So, what's the feedback you've had from customers? What was the use case to build this into the solution?
Oh, you mean the failover part? Sorry, I was looking at the comments and the question from, I think, R. Gagliardi there. Yes, I think the feedback here was this is great, but please have automatic failover built into this, because that's just the nature of the problem. I guess the cost of using LLMs everywhere. That is why you have multi-provide, I guess, not just within Foundry, but multi-provider access is a big deal as well right now. And you can see startups making big noise and that, hey, we go cross-provider and so on. So in general, availability SLA is a big part of just using LLMs of our work here that we do. And so that was a very automatic, very quick upgrade. I think we launched in February. That's what happens. So the idea here is that, hey, if the model that we targeted first is having trouble, then we go on to the next model. And of course, for this, what's needed is that if you're using a model subset, then make sure you're at least using 2 or more models in your subset. Otherwise, we will not have a model to fall back to, actually, if you're in that case, because we do want to make sure that, we are only falling back to your preferred models if you actually have a subset defined. So that's the only caveat here.
Yeah, and that's a really key point. But again, if you've got organizational governance around specific model families, so you might just be a GPT shop and run GPT models. Yeah. Model router is great for doing that. You can just select GPT models, or if you just want to use the XAI models, or if you want to just use the Llama models. There's a really great question by Galini.
Yeah.
So you saw it. I was like, oh, that's interesting. So tell us a bit about this. His question was, a model router could help a lot, but does it understand the business context properly to define the best model?
Yeah, so totally valid point, actually. So that's why we say sometimes you don't have to use model router everywhere, right? Especially if you know your scenarios really well, you already benchmarked the model and you think this model really works best and no other model will work for me, then absolutely use that model for your scenarios. Now to address the point about, hey, sometimes, sure, I have a chat bot and so on, but you may not understand the context there and so on. So that's where I think we will be enabling some more customization levers, I would say. We are private previewing some features right now with customers right now. So for example, what if you could, let's say you could, I guess, fine-tune model router with your own training data, and that's being private previewed with customers today. So if somebody is interested, and if somebody is vested, they will invest their time, but then they will have to invest the time also to work with us, to evaluate, give us feedback. I think that's the main thing. But yeah, we are considering that. It's kind of very early stage, so we'll see where that goes. And there are some other things we are trying out. Yeah, but I think that's to increase the coverage. Remember, also, I would say some of the other features we have in Foundry, such as the agent optimization service, which I know Lee and I think you'll be covering that as well. So if you combine that and model router, we're exploring some things there as well. And so all those tool sets are available to customers, and other than model router being addressed there. But like I said again, I think the customization story is only going to get better very soon.
Definitely. So let's talk a bit about, policy enforcement. This comes around to the governance of how an organization can deploy and manage these models.
Yeah. So let's see. Sorry, I got distracted by a notification on my desktop. But yes, I think so. When we launched model router, customers said this is great, and this is also good that you allow our end users to select specific models, right? But again, it's not a controlled environment. And we're already using Azure Policy, especially enterprise customers are using Azure Policy to define which Foundry models are allowed, not allowed, and so on. And so could model router honor that, especially because model router is almost like a second degree of separation when it comes to selecting the individual models, right? That you can select as a model subset. So with this update that was launched and built, model router will actually honor your Azure policy, just like other models do. And so which means that if you go and try into model router and your policy is active at that time, because your end users, right, can only select the models that are actually permitted, and the other models will be blocked out with a notice saying, hey, some models are not available and so on. And this was a big deal for enterprise customers. So this allows them, unblocks them essentially, to make sure that the model router is also behaving nicely, their policies.
Yeah, definitely. So this is a live Q&A as well. So if you've got questions, please do ask us questions. We have Nitya who's in the Q&A chat as well. So Nitya's going to be answering questions as we're talking, and we'll feature some of the questions. So thank you for the questions so far. So let's talk a bit, about benchmarking. Benchmarking is really key to organizations to understand. And, we're going to be talking a little bit more as we go through this session on hill climbing and that progression of adoption of models. So what's available from a benchmarking perspective?
Yeah, so how do you actually evaluate a router, right? Evaluating LLMs itself is a well-known problem that I think has been attacked from all sorts of directions. We have good information, but when you bring in a router, now the dimensions really go up significantly. And so how do you even evaluate routing? And so this was an attempt to, first of all, get something out to customers. It's an open source repo that anyone can fork and build off. And, we have sample prompts there. But the idea here was to have a solution that allows you to evaluate on all three vectors, right, which is quality, cost, and latency, not just quality, because that's really when you're making model choices in any case, right? And so your router is essentially a value prop for all those three vectors. And so how do you bring all those three together in a nice solution repo? And thanks, Lee, for helping out, taking the repo to customers and so on. And you're building some awesome solutions on top of this already, which I think all the audience here can benefit from. But that was the idea. And now, along with that, what I can share is that we are bringing some of these improvements built into Foundry evaluation UX experience too, where you can select model router as a target model. And secondly, you will see very soon in Foundry evaluation experience and service, you will see cost and latency grading and measurement also appear, right, in addition to the quality graders that we already have today. In fact, Foundry Evaluation today has added your kind of the public benchmarking data sets too, that you can actually drop down, select, and then run model router and your LLMs on that. So that's happening within a matter of weeks here or days. You'll see that pop up in Foundry Evaluation as well. And so that's how this evaluation story will help customers understand.
Superb. Yeah, and again, I think benchmarking is so key to how everybody wants to do this. So, one of the key resources as well is about lab and resources. So can you tell us a bit about, the Foundry Agent Lab?
Yeah, this came about because I think customers wanted to, or everyone, all of us wanted to make sure that the model router actually works with all the Foundry agents and tools that we use today. And so again, and since we're all trying out and building and scaling up agentic scenarios, this was a great repo and solution again that everybody can fork off and build off that to show that you can use one model, which is model router pretty much being used in all the scenarios, except the actual underlying models gets used differently depending on which scenario and which tool. So actually, if you go from left, and this kind of points to the hill climbing story too, you will see the hello world, so to speak. Grok 4.1 fast was good enough for that. Tool calling 5.4 mini, right, comes into play. Now you're doing a web search. At that time, we had 5.3 chat support that came in quickly. Now, if you're doing data analysis, so this was a data analysis scenario, then now the model router is calling a higher end model to do that. And so you can see the variability of the models being automatically called. And that was the other part of why we did this repo. Now, if you combine, the interesting thing is you can combine this repo and the evaluation repo. And now what you have is an agentic evaluation test bed being ready for actually built up and adapted and so on that you can start iterating on. Yeah.
Yeah, excellent. And again, there's lots of great resources. And again, a lot of the evidence that these examples and scenarios build out is a lot of the business justification as well. So developers can take that justification back to the business decision makers and say, this is the reason to move to model router, these are the benefits, etc.
Yeah, and what I can share is that, as I think we have shared, Lee, between us in our chats, in our team chats, customers are the ones actually. I'm doing calls with these are big corporations and companies, and they are coming across this repos and solutions on their own. and they're pointing them to us back and saying, I really found this useful. And so now you will see these repos are being promoted as first-class things in our product docs for the same reason. So I would encourage, everyone to just go and go start these repos, go play with them, fork them, and then build on top of them for sure. Yeah.
And again, all these repos and resources are going to be shared. The slide decks will be shared with those links in, so that you'll be able to access these. So let's talk a bit about this new concept. Well, it's not a new concept, it's a new terminology, hill climbing. Can you tell us a bit about what hill climbing is and how the model router team is going to be utilizing it?
Yeah, it's funny. This weekend, I think I might, my LinkedIn post might mention this. I went actually hiking, right, at the Twin Falls, which is on exit 34 on I-90 East. And yes, it required climbing 2 hills, by the way. Not just a straight hill up and all the way, but you had to actually go up a hill and then come down again and then cross the second hill. So that staircase probably needs to show not a linear thing too. And then there were twin falls, right? So twin falls hike, which means 2 waterfalls. So by the way, if you can't make it to the bigger one, you have the smaller waterfall, which is the smaller outcome to go to. Other, not to mention the other, those mini trinklets, water trinklets. So, and that's, I thought, as I was walking that, I was taking pictures of just the waterfalls and the hills. And I think my wife and the kids were saying, why are you taking pictures of just those? And I said, well, there is something going on there, and then actually it was my daughter who said, oh, he's just trying to connect it to model router. so she was on it. Because she's a CS, I guess, graduate working right now. So anyway, she was aligned with that. But that's exactly right. You can use model router depending on what outcome you are after. Right. You can simplify the journey. Imagine model router as something that you're going on this mountainous, hilly climb. You never really know what is in front of you, what kind of outcome you want, but it allows you to dynamically change your wheels, change your things, and evaluate how you're doing, and then you can take that step. So instead of having to manually spend those cycles of starting with a small model, evaluating, benchmarking, moving on to the next big model, or vice versa, you could be traversing it from the other direction too. Right, you start with a really big model and you say, costs are too much high. Let's reduce it to a mid model. But all of that is really part of what we call the hill climbing and descending, I guess. And that's where model router can help you automate that process.
Yeah, cool. And again, we're going to be talking a little bit more about hill climbing in a set of demos that myself and Nitya are going to be doing in this session. We pre-record these videos, so if the audio does go slightly lower, please just turn the audio up on your side. But we have created a set of resources to talk us through this. So, the whole concept of hill climbing with the models is that selection of the right appropriate model. I think that's the key concept, isn't it? It's about, using the most appropriate model for the task that you want to do. So do you want to talk us a bit through this, Sanjeev?
Let's see. I'm looking at this slide for the first time. Let me just do graphic here. Each one, yes. And I think, and this is what we have been talking about, isn't it? And that everything is happening, everything that you have to do on a per request basis when you're evaluating your model choices for production. Model router is doing it, which is your request is coming in, and the router is actually evaluating your prompts in real time. Remember, you're not doing the evaluation; it's actually taking care of that for you. It is selecting a model. Right, and then it is sending your request to that model, which reports back the response, and then you're getting the telemetry. By the way, this points to the fact that we are doing even more work that customers will see on telemetry, on observability part of model router, right? So which means in the API and in Foundry, you will see information being shared as to why, if kind of fallbacks happened, for example, then you will know which fallbacks happened and why, and so on and so forth. So we are doing that, and so it is that continuous loop of understanding which of my workloads and prompts and requests are going to which models. And by the way, this really points to what we see internally is customer behavior, where customers are using model router to understand their workloads versus models, right? And so almost like an educational knowledge tool as well. Because it's everything, the cycle that we do outside, offline, is encapsulated in model router. And so that's what we are seeing interesting behavior from customers. So sometimes customers will use model router, they will understand what is really working for them. And sometimes they will move off model router into those direct models, right? Endpoints that they realize that, boy, yes, I know enough. Thanks to model router, I've learned about my workloads, which models it maps to most of the time. And so let me just use those for whatever reasons and so on, right? And so that's the loop.
And again, this all happens in milliseconds. So as a developer, this is not adding any additional overhead to that model or that inference. of the context.
Got it.
So, there's three real ways to run the hill climbing loop. We've got that A/B testing where we can compare two options. So it's like model A versus model B. We've got the model decomposition where we break the model down into the systems and look at how the model routes through that entire process of an application, which could be a multimodal agent or a multimodal design. One of the examples that I've been using is a network operations center. So there's lots of, so basically it builds a network operations center's dashboard where you have very simple messages. So you've got like an error input coming in. You want an immediate alert, which might use a very small language model, to then a very comprehensive root cause analysis, which is going to use a larger model. So, you need to look at that model decomposition of how your agentic solutions are built. And then the other one is really around that continuous routing. So like ensuring a model is there to actually make a decision instead of like per project level. So these are like the three key patterns that are available in terms of hill climbing. And we're going to go into a lot more detail in the samples. So if you're interested in learning more about Model Router, Sanjeev and the team have released this blog this week. So it's aka.ms/model router/updates. If you go there, there's a great section of resources. It links back to the evaluations and to the benchmarking tool sets as well. So please do look at that resource. I'm going to give you a quick demo now into using a new workshop that we built. So we built this new workshop which allows you to start looking at the models, and it's called Model Mastery. So this is a project being run by Nitya where we're trying to focus on the model availability across the Foundry catalog and then have specific workshops around the model types or the models to then allow you to get started. So this is about 18 minutes. I'm going to play this and please enjoy. And then if you've got any questions, please do ask them in the chat. Okay, so we've heard about Model Router from Sanjeev. So let's start with a simple example and workshop. We've developed this workshop, which is https://aka.ms/model-mastery/model-router. So let's start with a simple question. Can routing generally save us money without giving us quality or safety? The word without is important because a cheaper model on its own does not always win. A model router sits in front of several models and decides which one should handle each request. In theory, straightforward prompts should go to smaller, cheaper models, while difficult or risky prompts go to something stronger. But the saving is not only the real answer, it's if the quality of the answer remains good enough. And the good enough is based on three factors. It's based on quality, performance, or quality. Everything I'll show you comes from a live calls against the Microsoft Foundry project. We'll follow one practical loop throughout: deploy, measure, compare, and iterate. And importantly, the results include failures. I want to show you how the method helps us find weak configurations, not just celebrate the good ones. If someone asks whether this is the same as fallback retries after something goes wrong. Routing makes choices before the call. The same evaluation discipline can be applied to both. So first, let's look at the traps we need to avoid. The obvious shortcut is to send everything to the cheapest model. The invoice falls, so it can look successful very quickly, but every error rate, retries and escalations can rise just as quickly. That matters because the cost of failure is not evenly distributed. A weaker answer to a routine question may be inconvenient. A weak answer involving account security or duplicate payments can create much more support work and potentially much more risk than any token ever saved. So I'm going to separate these four things. We care about cost and latency. These are objectives. We want them to improve. Quality and safety are flaws. They're our minimum standard that savings cannot buy their way past. The real question is therefore, can we lower cost and latency without reducing policy compliance or account security quality? This sentence is our acceptance criterion for the rest of the session. If someone asks you how to put a price on a wrong answer, the honest answer is that we usually cannot do this precisely. That's why quality and safety work better as gates than in terms of cost formulas. Now let's put that question into a realistic support scenario. The scenario is North Star devices. It's a fictional and privacy safe, but the routing choices, token counts and latencies we'll see are live. There are three pressures in the workload. First, a carrier outage creates large volumes of repetitive, time-sensitive queries. This is the easy majority where routing should save money. Second, a duplicate payment bug needs accurate classification and the correct next steps. A wrong answer creates additional support work. Third, a phishing campaign is a high risk and must be recognized and handled through the approved response path. Think of every support case as a prompt. This mixed workload is exactly where routing becomes interesting. Most traffic is relatively simple, while a small proportion needs more capable or tighter control. With one fixed model, we may overpay for the easy work or underpowered for the most difficult work. I often ask the question, which is the case and which is the most nervous about automating? Usually the phishing cases, and this is because it reminds us of why high-risk slices need to have their own gating. All the data in this workshop is synthetic, so we can run this and reproduce it and share it safely. Before production, we will replace it with appropriately governed representative data sets of our actual scenarios and organization. And with this scenario clear, here's the methods we're going to use to test it. The workshop uses one repeatable loop: deploy, measure, compare, and iterate. First, we look at the deploy control choices, making sure each experimental arm differs by one lever. Next, we measure the same evidence for every call, which is the route which was taken, the token usage, the latency, the quality scores. Then we compare each candidate with a fixed baseline, not whichever ad hoc run happened to come before it. We actually have a managed pipeline. And then we iterate by changing one thing and running the same test again. This is essentially hill climbing. You keep the current best options, make one control change, and retain it only if the evidence improves. It's not glamorous, but it's defensible because we can explain why each configuration was promoted or rejected. The promotion rule is the key discipline. No candidate moves forward unless it improves the agreed objectives and still clears every quality and safety flaw. For timing, a 20-prompt smoke test can take minutes. A real promotion decision should use a large representative data set, often over 100 prompts or more, and will naturally take longer. Let's now look at all three controlled arms that will make this a fair comparison. We'll begin with three deliberative simple arms. Arm A is a baseline GPT model, one fixed model, no routing. This is the benchmark every router has to beat. Arm B is a router GPT family. Routing is enabled, but the eligible choices are limited to approved GPT family only models. This tells us whether routing within one family adds value. An Arm C is a router using open weight models. The router stays the same, but the eligible pool changes to open weight families. Between B and C, that model family is the only other lever we change. Everything else stays fixed: the data set, the judge, the pricing snapshot, the region, the mode, the concurrency, and the ordering. If we change several things together, we could not tell which one caused the results. The allow list also matters for governance. It prevents a router from quietly selecting a model the organization has not approved. And within model router, as Sanjeev showed, you can select specific models, model families, or choices. We could add fourth arms or fifth arms to this, but we should consider what those levers are and how we're going to test those changes. Once those arms are defined, the next step is to prove the deployability actually happens and the deployments actually happen and the deployments actually match what we intended. This is lab 0. This is the trust, but the verify step. The deployment script does not stop when we create request is accepted. It reads the deployment back from the management plane to validate those models that we've selected are actually deployed. First, it resolves the requested models and confirms that it's exact in its selected region and support and the deployment models that we need. It then verifies the actual provisioning state, model versions, SKUs, capacity, and routing subset. Finally, it writes the real deployment names into the environment file, so the notebooks use exactly the configuration we tested. This matters because submitting a request is not the same as proving the correct deployment landed. A different model version, capacity, or region could slightly invalidate the comparison. The script assumes the account permissions and quota already exist. If quota is refused, we want to discover that here, not halfway through the evaluation run. For a live session, I'll show you the save verification outputs rather than risk waiving on the deployment. The teaching point is the read back and the recorded configuration, not the console itself. With all 3 arms verified, we can run the first live router test. Lab 1 is a qualification run. It uses 20 synthetic cases, 12 core cases, and 8 challenge cases with no customer data. The cases over classification, policy retrieval, summarization, and constrained reasoning. That range matters because a router may look at strong on one task and weak on another. For every call, we capture the underlying model selected, input and output tokens, latency, the response, and the quality indicators. Recording the selected model is particularly important. It turns a vague claim about savings into an explainable routing decision. So the goal is to deliver to limited. We're asking whether the router is credible enough to become a candidate for a large comparison. Passing would not be a production sign-off. And we're only using 20 cases. This is really around speed. A small run exposes obvious issues quickly. Lab 2 is where we use a larger set to support promotion decision. Now let's look at what the router actually did and the results, and if there was a clear winner. Here's the obvious evidence from a point-in-time run. Across 12 calls, the router used 3 underlying models. It consumed 650 tokens and 4,672 output tokens. Median latency P50 was 36 seconds, while P95 was roughly 95 seconds. So the slow tail was more than twice the median. Most importantly, the quality pass was only 58%. That's below any sensible promotion floor. The router selected GPT-5 Mini, GPT-5 Mini, and GPT-5 6 Luna. So it was generally different between different prompts. The problem is not it failed to route. The problem is that some of the routing choices were not good enough for the task. For anyone new in terms of these terms, P50 means half the calls were faster than the value. P95 describes the slower user experience that often generates complaints. Tokens are the billing unit that serve as a cost proxy here. This is a credibility point for the exercise. A useful method must be able to tell us when a configuration is weak. A larger run might shift to 58%, but we should not use that as a sample size. We need to fix the configuration and all the tasks fit. To understand what failed, we need to stop and look at the averages and examine the slices. The overall score hides 2 different stories. Classification was strong. F1 was at 1.0 on all 3 classification cases for that slice. Efficient models were sufficient and potentially economical. Summarization and constrained reasoning were much weaker, with F1 scores of 0.19 and 0.31. Those prompts need more capable and selected models provided. This is why I report core challenges and high-risk slices separately. An average can look acceptable, while higher and concentrated failure in part of the workload that matters the most. For this candidate, the gates are straightforward. Complete the requests, classify the queues correctly, achieve at least 80% quality, and pass every high-risk case. A cost saving cannot compensate for missing one of those gates. F-run ones on 0 to 1 and balanced position and recall, the exact definition matters less here than the contrast between the slices. Also note that the tokens are cost proxies. For the promotion decision, we'll use a dated price snapshot using the Azure Retail Price Index so that a financial comparison remains stable. Could we force harder tasks to stronger models? Of course, yes, we could. And this exact example of the next lever we're going to experiment. By moving into the larger comparison, let's look at how we share the evidence safely. The export to results is designed to be useful without carrying the sensitive text. We remove the original prompts and the generated responses. We retain the selected routes and models, inputs and output tokens, latency and evaluation scores. That leaves the information needed for decisions, cost, speed, routing behavior, and quality, without circulating free text content. It means the evidence can travel to finance, security, or change review boards without automatically creating a data handling exception. Redaction does not remove the need to follow your organization policies, but making the shareable export the default removes a common blocker. For debugging, keep a separate full export in a restricted access controlled location. The wider audience should receive only the redacted version. Now we can move from qualification to controlled head-to-head experimentation. For the promotion decision, we need to measure quality and safety tokens usage against a date price, P50 and P95 latency errors and retries, and the distribution of selected models. The last measure tells us whether the router is truly routing or quietly defaulting to one model. This sequence matters. First, it proves that B beats the fixed model, A. Then promotes C only if it's clear that the same quality and safety flaws and improves the objectives we agreed in advance. If a candidate fails, we keep the better arm, change one lever and rerun. We document the failure as well as the success because that stops us using the same unsuccessful ideas being rediscovered every quarter. A 20 prompt set is useful for smoke testing. A set of 100 or more represented products and prompts provides much stronger evidence for promotion. These results are not permanent, and we should run whenever the model prompt pricing or policy changes. So stepping back from the lab, there's 3 practices I want everyone to take away. First, use constraints. Say cheaper without losing quality or safety. The word without turns a broad ambition into a testable decision rule. Second, slice the evaluation. Report the core challenge, the high-risk group separately, because a single average can hide the failure that matters the most. Third, keep a baseline. Compare every router with a fixed configuration. Use an independent judge, change one lever at a time, and anchor cost to dated pricing snapshots. Put simply, define success before running tests. Look beneath the averages and always keep something fixed to measure against. The result is evidence we can defend in change review meetings, rather than a hunch about the configuration which we feel is better. This approach also applies beyond routing. The same works for agent changes, prompt changes, or any other systems adjustments we want to promote based on evidence. If you do only adopt one practice this week, start by writing down the constraints before running your next test. Let me finish with the simplest way for you to try this. The practical next step is straightforward. Deploy the 3 arms, run the smoke test, then run the review and the redacted scorecard. Everything runs against your own Microsoft Foundry project. The supporting resources cover model router concepts, the implementation guidance for an auto-evaluation toolkit, and I recommend start with the synthetic prompts. They'll let you confirm the deployment, routing, measurements, reporting, all the work end to end. Once that workflow is stable, substitute a representative dataset from your own workload using the appropriate governance and access controls. The smoke run itself is small. The main costs are deployment and the team's time, so begin narrow and expand only when the evidence is justified. Check out the repository at https://model-mastery/model-router. router. That was a quick demo of how model router runs. So now what we want to do is move on to our next section. And if you want to try any of this, you can go and try these resources. So here's a resource link to the blog. You've got hands-on with the actual resources here. You've got access to the evaluation, you've got access to the benchmark, and you've also got access to those labs. So thank you for joining us on that. The next section we want to look at is a demo by Nitya, talking a bit about all the hill climbing process. And we've created this resource called model releases. So again, what we're trying to do is have single resource centers for all this content. And what we're going to focus on is how to build my model optimization for Microsoft Foundry based models. We have different models available. And again, we're going to focus on the model releases for each of those models and have this resource available. So this is a demo by Nitya on hill climbing.
So today you heard about Model Router and you got a taste for what a hill climbing journey could look like. But Foundry has hundreds and thousands of models and new ones dropping every minute. The hard part isn't picking the best one, it's having a repeatable way to decide. So that's why we need to all think about model optimization playbooks when working with Foundry. In this model releases repo that I'm going to share today, we keep one consistent scenario for tracking our hill climbing. It's a policy compliant travel concierge. There's a request, fly me to Berlin on Monday, book me a hotel near Alexanderplatz, stay inside travel policy, and expense my attached parking receipts. It's one sentence, but it's 4 jobs. I need to understand the intent. I need to read the receipt. It's visual too. I need to check the policy and I need to plan and act, and I have to do all of this in a correct, compliant, usable, and production ready way. This is where hill climbing really helps. With hill climbing, the process is simple. You pick one target, cost, quality, or latency. Then assess where you are currently with respect to that target. Then identify optimization levers that can help you move along that target. Pick one and pull it. Then evaluate whether pulling the lever actually improved that particular target. If not, discard it, pick another lever and try again. But if it did, deploy that model, have that reevaluation be the basis for figuring out what your next optimization step should be. So it turns out that the simple way is not to start by trying to make it work. Not by trying to make everything good, but just trying to make it work. And the easiest way to do that is to put a frontier model in. Let one model do all 4 jobs. That's your baseline. That's your measuring stick. Once you've done that, let's say you want to optimize for cost. Then you can look at what are the optimization levers currently available for cost optimization. Turns out there's a lot. There's inference tiers, there's model routing, there's batching, caching, structured outputs, distillation, token budgets, prompt optimization, and so on. And typically we all start with prompt optimization. We'll look at that briefly later. But today we talked about model routers. So let's kind of nudge that a little bit. So if you're thinking of model router, how would you use it to optimize your model selection? Well, step 1, remember you had built it with a frontier model? Just replace the frontier model with model router. It's one change. 4 jobs, same 4 jobs, now auto-routed to a right-sized model, and you only changed one lever. Remeasure. Did that help? If so, leave model router in and take the frontier model out. Step 2. Model router doesn't just help routing, it gives you insights into how your actual agent architecture should be structured. The router shows you what each task actually needs: a tiny model for intent, document and vision models for your receipt, strong reasoning for policy, and top-tier thinking or planning and tool calls. And this map that router gives you, that's the real prize, because there might be other models that router doesn't currently support that might give you an even bigger boost. So if you want to go past the router optimized step to the next climb, you can look at that. So step 3, decide. Now you have 2 choices. If the models that are within model router can get you all the way there, you still have more levers to pull. You can configure the model subset that you use in model router. You can try tuning the balance, be more towards cost rather than cost and quality balance. Try using a model router per agent. Every one of these is one lever to pull that you can then assess and then figure out if you want to stay with that. Agent Optimizer is kind of the catch-all that can run in the background against your production traces and give you insights into whether combinations of model optimization, prompt optimization, and other things might help you improve at scale. So that kind of is a really quick spiel about the model releases repo that we want to share today. You can go find that at that particular link. Particularly, you'll see the model router folder in there that you can kind of explore. We have a few notebooks in there, but throughout August, we'll be dropping additional notebooks. Each one should help you figure out how to use one particular facet of model router. For example, the routing subset or the balance, and see how that impacts your hill climbing journey. But we can also go look at the repo in action and just get a sense for some other things that you could do. Here's a model releases repo. Note that it contains a models folder with one folder for every core model provider in Foundry. So when we covered Microsoft AI a couple of weeks ago, you'll find all the notebooks that teach you how to work with Microsoft AI over here. Model releases, we talked about this Contoso Travel Concierge. You can find the demo app in this repo and instructions on how you can deploy it. When you do that, you can go ahead and then deploy the models that you want to test against, and then go into that model folder and run their notebooks to see whether you can build your own intuition for how that model can help you with that particular step of your hill climbing journey. And last but not least, under Model Router, we actually have a set of notebooks. The first one, for instance, will help you set up a custom rubric evaluator that can replace the collection of base evaluators or built-in evaluators you need with one that's custom built for this particular travel agent use case. And it helps you upload an evaluation data set. Now you have two things, an evaluator and a data set that you can use consistently across different model releases to see how they perform for your hill climbing journey. Finally, for Model Router itself, you can actually follow these notebooks to come up with a very simple pattern of how you deploy an agent with a particular model, run the lever, and then understand what it actually did before deciding whether you want to keep that version or regress. So as an example, this is the Travel Optimizer agent that will help you run an agent optimizer on the Travel Concierge. Here's an example of what that looks like when it's run. What the agent optimizer is actually doing here is it goes ahead and helps you create an optimization run using the evaluator rubric that you previously set up with that evaluation data set. And once it finishes running, it comes to you with options that tell you options that tell you what the outcomes were for that climb. Do you want to use candidate A that just used a prompt optimization, or candidate B that did both model and other optimizations? And then based on that, it recommends the right one that you should deploy. You can go ahead and deploy that prompt, promote the candidate, and now you have that same frontier model with an optimized prompt that gives you a better outcome. The model router examples are going to show you notebooks that help you set up model router for routing and test out levers one at a time. For instance, here, we can look to see how we can configure model router to have a cost priority or a quality priority or a balance priority, and then get an intuition for which one did best, what model it picked, and how that impacted our climb. With that, let me bring us back to the slides. So if you're interested in this, please do check out the repo and keep an eye on it all through August, because we will be updating these with more notebooks that should help you understand how Model Router's various capabilities can help you test out and build intuition for hill climbing using the Contoso Travel Concierge use case. Thanks, and until the next time.
Great, so thank you to Nitya for that demo. Again, all these resources are available, so please do go and download and try these samples. So next up is Shamila. So Shamila, great to see you. We're going to do our weekly highlights. So what's new in Microsoft Foundry this week?
Hey, Lee, great to see you too. And yes, let's jump into it because I know we are running out of time. So first of all, I wanted to kind of quickly call out. We've been doing this is not just a one-time announcement. We've been launching a bunch of open models in Foundry, both as a direct from Azure model or through a Hugging Face partnership. I just wanted to call out the two models that we kind of launched last week, the new DeepSeek model, as well as the NVIDIA Nemotron models. These are available through Fireworks. That's another partnership we recently announced. So we are doing all these kind of partnerships to make sure that we give developers more choice so that they can optimize using any of these models from their favorite platform, and they can optimize it across agentic workloads, cost, latency, everything. And actually Foundry, so teams can select the right intelligence for each workload rather than standardizing on a single model. So that's what I wanted to call out on this one. And then moving on to the next highlight. So last week, I quickly, during the highlight, I mentioned that we are bringing more tool capabilities with our Claude on GA in Foundry. And some of those capabilities are like structured outputs, web search, web fetch, MCP connector, and tool search. And all those are like, we are removing like some of the barriers that developers used to have because it was available only hosted on Anthropic. Now it's all hosted on Azure. So you can quickly go and start using those models. And also, we have put together a great blog post on this where we go into the details of how to use each of these tools with some code samples, with some scenarios. So you can go and take a look at the blog. Moving on to the next highlight. Again, these are the next two highlights are more of like guidance, like some best practices or how to build certain things. And this is the first one is how to build a safe agent. And as agents are gaining autonomy, safety is becoming it needs to extend beyond just your model level guardrails to what an agent can actually do at runtime. So this blog goes into a kind of a safe framework, and it focuses on 4 principles like scope, anchor, decision, flow, integrity, and escalation, and demonstrates how Microsoft Foundry and then Azure Content Safety can be used to enforce and validate those controls. And it's a great blog post, is very detailed, so go ahead and take a look at it. And moving on to the next highlight, this highlight is around 10 lessons for taking agents from demo to production. And I found this pretty valuable because it's like a practical guide that shows you how to build production-ready agents. In Foundry, it covers architecture, it covers tools, it also goes into observability, evaluation, and all the operational considerations that become critical when agents encounter real users and real-world complexity. And again, these go around the same principles that were shared earlier with model router and what Nithya and Lee were talking about, like the hill climbing part of it. And that's what our next highlight is. And finally, the last highlight is, of course, our very own model router. You heard a lot about model router today. The blog, the new updates that were launched in model router, there's a blog post on it. And of course, you heard about the hill climb. So the blog post goes into that hill climb and whatever Sanjeev mentioned earlier. So this is just another resource for you to go and take a look at what we already went through in detail earlier today. And that brings us to a end of more weekly highlights, and hope to come back again next week.
Cool, thanks, Jamala. I think one of the key ones for me is Nemotron. I love the Nemotron model. Anybody who's tried voice in the GitHub Copilot app, that's actually using Foundry Local and the Nemotron model to do the live audio. So again, if you turn on voice mode, give it a try. That's using Nemotron. It's pretty phenomenal. Yep. So huge thank you for joining us this week. You'll be back next week with what's new in Foundry. And again, let's talk about what's next week. So next week we have From Research to Reality. So our host will be Nitya. Nitya will be live on the stage. She will have Gazimo and Yash and be talking about the new MII models and what's coming out of Microsoft Research and now coming into reality as new models and new services around Core AI. So please do join us next week at 1:30. Again, if you want to watch this, you can watch it live. So thank you for joining us live. You can join our community on Discord and have discussion and access, and we'll also have the resources available there. We do have a dedicated GitHub repo, so please do visit the repo. That has a summary of all the content that we've covered on each session. It has links to the blogs, it has links to the decks, it has links to the resources. So we have a great set of online resources all around Model Monday. So the URL you just need to remember is aka.ms/model-mondays, and everything is there. So huge thank you to everyone joining us today. We hope you've had a great time. So huge thank you to Sanjeev, huge thank you to Shamila, huge thank you to Nitya who's in the chat. And again, I hope you've found this useful, and please do join us next week at Model Mondays.
Thank you all for joining. And thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.